Welcome to the next chapter, linear inequalities. In our previous classes, we've solved many equations like x plus 5 equals 10 or 2x minus 3 equals 7. In every equation, we were trying to find a value that makes the left-hand side exactly equal to the right-hand side. But in real life, many situations are not about equality. They are about being greater than, smaller than, at least, or at most. And this is exactly where inequalities come into the picture. Let's understand this with a simple example. Suppose Ravi has 200 rupees and wants to buy rice. Each packet costs 30 rupees. If he buys X packets, then the total money spent is 30x. Now, can Ravi spend more than 200 rupees? Of course not. He may spend less than 200 rupees, or if the amount matches exactly, he may spend all 200 rupees. So instead of writing an equation, we write an inequality. 30x is less than or equal to 200. Now consider another example. Reshma has 120 rupees. She wants to buy registers costing 40 rupees each and pens costing 20 rupees each. If she buys X registers and Y pens, then the total cost becomes 40X plus 20Y. Since she cannot spend more than 120 rupees, we write 40X plus 20Y is less than or equal to 120. Notice something important here. Both of these statements use symbols like less than or equal to instead of the equal sign. That is the main difference between an equation and an inequality. An equation tells us two quantities are exactly equal, while an inequality compares two quantities and tells us one is greater, smaller, greater than or equal to, or less than or equal to the other. In mathematics, whenever two expressions are connected by the symbols less than, less than or equal to, or greater than or equal to, we call it an inequality. There are different types of inequalities. For example, 3 is less than 5 and 7 is greater than 5 are called numerical inequalities because they contain only numbers. Expressions like x is less than 5, y is greater than 2, or x is greater than or equal to 3 are called literal inequalities because they contain variables. Sometimes we combine two inequalities together. For example, 3 is less than x is less than 7. This simply means x is greater than 3 and at the same time less than 7. Such expressions are called double inequalities. Next, let's understand another important classification. Strict inequalities use only the symbols less than and greater than. For example, x is less than 4 or x is greater than 2. Here, the boundary value is not included. On the other hand, slack inequalities use less than or equal to and greater than or equal to. For example, x is less than or equal to 4 or x is greater than or equal to 2. Here, the boundary value is also included. This small difference becomes very important while drawing graphs and writing the final answer. We can also classify inequalities based on the number of variables. An inequality like 2x plus 5 is greater than 9 contains only one variable, so it is called a linear inequality in one variable. An inequality like 3x plus 2y is less than or equal to 10 contains two variables, so it is called a linear inequality in two variables. In this chapter, our main focus will be on solving linear inequalities and representing their solutions graphically on the number line. Nikyoki. These concepts are not only useful in mathematics, but are also widely used in economics, business, statistics, engineering, computer science, and optimization problems.